how many category of architecture and what are the architectures inside each category. For example, if I ask you, pipe and filter should be under which category of architecture, or if I ask what's the difference between batch sequential and pipe and filter, so by right you should know the difference, right? So I hope you have a good discussion with your tutor during the tutorial and practical about your assignment, because I'm not sure about how the other tutorial group do, but in my group, what we do is that we use the practical session basically as part of the revision session, as we discuss how to complete the assignment every single week. Alright. Then we also discuss about the importance of architecture. So basically, part 1 of your journey for software development and architecture, BACS 2073, should end last week. I just purposely did not want to open that because sometimes it's good to have an effort, but the moment you goncang the pintu more than 5 times, it means that effort is useless, right? time to move on. So same thing like life lah. Okay. so basically, use that as your life philosophy class for today. Okay, observe and learn. Okay, observe and learn. Okay, shall we start our second journey? So today we are going to start our journey in detailed design, which is part 2 of software design. So whenever you do software design, even in the industry, so we always split our works into 2 sections. One is called architecture division, another one is called detailed design. So under detailed design, there are actually a lot of things that we do. Right? We need to identify what are the components. We need to identify, let's say, in the perspective of object-oriented programming or object-oriented analysis and design, we also need to discuss about class. We need to discuss also about strategy. Okay, and then from each strategy, we are going to find what are the problems. Okay. And then in order to identify component and class, we also need to know what are the issues that we are going to solve, so on and so forth. So this discussion will start today up until hopefully before your week 7. Yeah, by the way, just a reminder, our midterm will be in week 7. Unfortunately, I will not be seeing you, especially for the tutorial and practical group, on Monday and Tuesday, right? Because I'm going for training. So I'll see you on Wednesday, on the day of the exam itself. So please remind those who are not here, your midterm will be on week 7, Wednesday during lecture, covering chapter 1, 2, 4 and 5. Okay, chapter 1, 2, 4 and 5. So that's already mentioned in the classroom. Okay, before we start, any issues or any questions that you would like to raise? Anything or any discussion during lecture and tutorial which are not which doesn't match up, or there's a big difference between what is discussed by your tutor and also me? No? Everything is okay? No issues? Right, cool. Let's begin. Okay, sorry, I'm stuck to this desktop. Somehow the HDMI is not working. So detailed design. So now what happens is that when you do architectural design, you are doing a high level design. So as I mentioned many times, architecture provide a general view or provide an idea how your system will be arranged. Alright, so meaning that as if like you are looking from the top. So when you look from the top, you can see the structure of your software. How the software is divided into different sections, or we call it a structure in architecture, and how each section communicate with each other. Right, so that is called architecture view. So by right, when you see the architecture, one question can be answered: what are the quality objectives supported by this architecture? Means that when you look at the architecture, you know that the architect aim to achieve a certain quality objective, and that answer is given by the drawing of the architecture itself. So that is called high level design. activity. So now what happens that we want to go down a little bit lower. So now we want to fill up all the gap in the architecture. Right? So what happened now is that, let's say I choose to develop my system using a 3-layer architecture. Okay. So what happened now, I want to know what do I need to fill up here. So basically you should have some idea what do you want to fill up inside each layer. But now we want to go more deeper into the discussion. How do I want to decide, or what kind of things that I can put inside each of the structure in my architecture. So that is the main purpose of this particular chapter 2, chapter 3 and chapter 4 discussion. Okay, chapter 2, chapter 3, chapter 4 will focus more on this kind of discussion. Okay, moving on. After high-level design, a designer should focus its shift to low-level design. Means that we need to understand the responsibility that need to be specified precisely. So means that now, let's say if I say this is GUI, I have 5 modules: finance, academic, student affair, staff, and let's say, academic, finance, student affair, human resource, let's say external monitoring. So I have 5 modules, but I have only 1 layer for GUI. So how do I want to include the GUI for 5 modules inside 1 layer of GUI? That will be the question that you need to ask now. So that's what we mean, to ask each module responsibility, to identify the responsibility as precise as possible. Constraint. Okay, next one is constraint on the use of its interface. When 2 components talk to each other, right? When 2 components talk to each other, they need to pass parameter. Right? Passing parameter requires some kind of format, requires some kind of rule, or some kind of condition. So this format, rule, and condition will be defined in your interface. Okay, so there will be one discussion about interface. Okay, component interface. Then we need to identify the pre and the post condition. Means that what will happen before and after I introduce this particular component. And module wide invariant. Module wide invariant means that what are the value that keep on changing? What are the value that is fixed? We call it as module wide invariant. Means that throughout the system, regardless whether the components sit under GUI, business logic, or data layer, the value will remain the same. The parameter will remain the same. So that is called module wide invariant value. So that also will be required to be answered, right? And then of course we have to discuss a bit about internal data structure and algorithm. Okay, however, there is a disclaimer, or there is a precaution statement saying that as a software designer, do not overdo your design. Now, sometimes designer, they have this kind of not worry, but this feeling that if I do like this, not enough. I need to add more component. I need to add more classes. I need to add more layer. I need to add more interfaces. Not to make it more detailed, to give more information. So what happens that if you do that, if you have that kind of attitude, what happens that you will overdo your design. When you overdo your design, there is a possibility that you will introduce unnecessary complexity, unnecessary hardship for people to understand your design. And most important of all, when you overdo your design, there is a possibility you are going to increase the time. The time taken for you to develop the system will definitely go up a little bit. Why? Because you introduce too much complexity in your design. So please be very, very careful when you do a software design activity. When you do the second part of the software design phase, make sure don't overdo it. Okay. How am I supposed to know whether what I have done is complete? The answer to that will be as long as, okay, this is the nice thing. In software architecture, how do you know you choose the right architecture? The only one answer: if the architecture support the quality objective of your system. Done. But in software design, if I want to know if all, okay, let's say let's make it something that is easier for you to understand. How many class must I have in my class diagram? 100, 50, 1000? The answer to that will be this. As long as all your class diagram can cover all the functionality requirement stated in your SRS, then your software design is considered complete. Let's say I have 100 functionality requirement identified in SRS, right? Then from that 100 functionality requirement, okay, let's say from 100 functionality requirement, then when I draw my class diagram, I can only identify 60 class diagram. But when you look one by one, if you can map every single function to any of the 60 class diagram, maybe some classes will handle will handle more than 2 functionality requirement, is okay. But as long as all functionality requirement can be mapped to the class, then your software design activity is considered as complete. Don't overdo it. Okay, don't overdo it. So the mapping between your class diagram and also your functionality requirement, that will be the only benchmark that you can use to assess or to identify if your software design activity has reached the end. Okay, has reached the end. Right. There are 2 other ways where you can over-specify your design. Number 2, we do not want to express a module detailed design using a programming language. Okay, this is the worst case scenario. As I said, software designers are very well experienced technical person. They are very good in requirement. They are also very good in coding. Just that they don't like to meet people, so that's why they don't become analysts, and they don't want to spend time in front of machine anymore coding, so they don't want to do programming, so they stuck in the middle. What they become designer. Okay, so this designer is a very techy guy. So what happens is that when you do class diagram, sometimes when you do the description, you have the tendency to write code. No? When you describe your class, or when you describe your method, or when you describe the algorithm in the method, what happens is that you have the tendency to provide the explanation by writing code immediately. So the problem by doing that is this. From programmer point of view, of course, they say thank you so much. Alright, you complete everything, you give me SDD, basically you're giving me a bunch of code. I just copy and I'm done. But what happens is that number 2, your coding may not be suitable with that particular scenario. Maybe there are other ways of coding to solve that problem that you don't know, number 1. Number 2, you are basically restricting the creativity of your programmer. Right. Programmer, as long as you tell them, okay, this class will do this class require this is the algorithm, or this is the pseudocode for this particular class. But when I translate the pseudocode into a real programming code, there are actually many ways for me to achieve that. So don't restrict the creativity of your programmer. Don't force your programmer to accept your way of writing code. And then the number 3 may not be relevant, but there are certain situations where the programmer might want to give some input. Maybe the programmer say, Ridwan, I think your design, can we change a little bit? This is my suggestion. For non-egoistic designer, usually they say, okay, come and sit and discuss. But those who have 10 years experience, 15 years experience, the moment the programmer say, can I give some opinion, he will look like, noted. Not noted, but he will never go back to the programmer. Who are you to ask to question my design? So that's a human factor. Right? So be careful. Do not describe your design using programming language. But at the same time, you also should not describe your design. I'm not good with Google Slide. How can I change my pointer? Anybody?
Slideshow first.
Slideshow.
Top right.
Top right.
Slideshow.
Oh ya, slideshow. Boleh lah. Turn on the pen. Alright. Okay. Next one. This one. Okay. At one extreme, at one spectrum, you describe your design using programming language. But at another spectrum, you write everything in natural language. Rizwan, I don't like diagram. I'm not a person who like to draw. I want to do art actually, but my parents forced me to do IT. So I'm using this opportunity to write SDD as if I'm writing a novel. Everything words. What is the main problem with human language? I asked you to learn life philosophy from that incident, but your face to me. Alright. What is the main problem in natural language? What is the main problem when you use natural language to describe something?
Ambiguous.
Any idea? This is discussed during SRS.
Too hard to catch the point.
Too hard to catch the point. In a much more clearer way to say it.
Ambiguous.
One statement can have different meaning. That one sentence for that.
Amalgamation.
You give a definition for one word for that. You give a definition for a word, something that can be defined in many ways, and that word is
Misunderstanding.
huh? Sorry. Oh yeah, that word. Something right. That's too high. Let's use a lower English sentence. Yeah, I remember that word from the tutorial. Hate that word. Yes. Come on, boys. Bro, forgot already. Alright, cool. Anybody from the middle row? One word to say that what she said just now. Something can have different meaning. Different people read one sentence, it gives different meaning, and that word is
Understanding.
not misunderstanding. Other than that, ambiguity. Thank you. Right, lower a bit okay lah compared to what was now? Imagism something. Alright. Ambiguity means that something sometimes certain words or certain statement when you listen to it, different people interpret differently. Same goes to sentences. When you read things, that's why if you got mad or if you want to say something or if you're involved in a fight, don't fight in WhatsApp. The meaning can be different. No? The meaning can be different. Some people read your WhatsApp as if like, okay, I'm okay. Some people say you're being sarcastic. Some people say you're being mad. No? Just call. Okay, just call. So same thing in writing SDD. If you write everything in natural language, what happens is that some people will misinterpret the detail. So what happens is that you need to balance out between natural language, technical language, which is programming language, but the most best way to represent information in SDD is by using diagram. Okay, use a diagram. So remember, do not over-specify your design. Okay, do not overdo your design. There is actually a principle we call as KISS. KISS, KISS. Stands for? Why you smile so broadly? Thinking of doing that anytime soon? I thought you single. You're single. Okay, cool. KISS. There is a principle in software design, we call it as KISS. In order to remind everybody, don't overdo things. What is KISS? Anybody heard that term? KISS. KISS. In a good manner means that keep it short and simple. But if the person still don't understand, keep it simple, stupid. Depends on the person that you talk to, right? Depends on your subordinate, your orang bawah lah, your programmer or whatever. Depends on people, right? Depends on people. Alright, KISS, keep it sweet and keep it short and simple. As long as it fulfill all the required functionality. Alright, so now where do I start detail design? Detail design start immediately after your architect identify the architecture and finish with the architecture. So the architecture has been reviewed, right? Most important thing is this, your architecture must be reviewed. Means that it must be validated by somebody. Usually we call for a review meeting. Review meeting is considered as static or dynamic testing.
Static. Static.
So review meeting is one of the technique under static testing. Okay. So make sure every output that you produce in every single phase, it must be validated. It must be validated and verified. Since we don't have a program, so we use a static testing technique. One of them is called a review meeting. Right. So now deal with the implementation part of what is seen as a system and subsystem. So basically now we are focusing. Now we are changing back our focus to functionality requirement. When we do architecture, we never discuss about functionality requirement. We even put it aside. We focus on NFR, non-functional requirement, and also the quality objective. Now we redirect our focus back to functionality requirement, because now we are developing something, or we are creating something to show how does this functionality requirement will be translated into coding. So we need that diagram. Right, more detail towards module and their implementation, and it defines the logical structure of each module and their interfaces to communicate. So even we are talking about functionality requirement, but they also have structure. Right, component is a structure, package diagram is a structure. So all these things need to be identified, and how these elements communicate with each other. So these are considered as detailed design. Right, there are two major tasks in detailed design. Okay, there are two major tasks that you need to do in detailed design. One is to identify or to describe the interface design. As I said, when you identify component and you want the component to communicate with each other, you need to identify the rule, the condition, and the format for the communication to happen. Okay, let's say I have one folder. Let's say I call this folder as finance, right? And then I have another folder. Let's say this one I call student. Right, I know that student and finance will communicate. But okay, let's say they are communicating like this, right? So I have two components communicate with each other. The issue now, what is the format that I need to send? What is the data that I need to send? What is the condition? Meaning that if I pass the parameter within 5 minutes, if I don't receive any output, what does it do? How does it respond? Okay, and then what is the output, for example? What is the expected return value? So all these things is called interface. Right? So this is called interfacing. Right? This is called interface. We are not discussing about the interface element in Java programming. No, we are not discussing that. We are discussing about two components talking to each other. There must be some format, some rules, some condition that I must follow. So to define the rule, the format, the condition and whatnot, I need to do interface design. Okay, and then number one we do component design, then we do interface design. Sorry for that. So number two, component design, is for you to identify all these things. Right, all these components that you need to develop. Okay, again, let's take architecture. Okay, let's say I have 3-layer architecture. Again, I go back to 3-layer architecture. Okay, let's say I have two modules. Number one is called student module, and then number two I have finance module. Okay, let's say right, maybe for one designer, he's not lazy lah. Maybe he says, I just want to, okay, version number one. Okay, let's say I focus on this particular box here. Let's say I zoom in. Okay, I zoom in. Version number one, maybe he will say, I just want to put two folders. One folder is called finance, and one folder will call academic. So all business logic, all validation, all process will be done here and here. Done. Can I consider this as component design? Yes. But does it give me a detailed information? No. Is this a good design? No. Right. So let's say we use the version 2. Right. Maybe now I'm going to say, okay, I'm going to have one. I'm going to use folder also, but this time in finance I'm going to say fin. Okay, let's say I have one component. I call this. Okay, this is finance. So under finance, now I have component. This is not class diagram. Let's say I have one component, cost salary. let's say one component called fee, one component called extra credit, one component called penalty, one component called registration fee, blah 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 blah. And each one of these components start to communicate with each other using a certain rule and format. Then what I do that I create another folder. So this is for student. Now I have registration, I have exam. Okay, then I have, let's say, result. I have I want to do payment, blah 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 blah. Alright, and I know that this payment will communicate with the fee folder. So I need to create dependency or relationship between these two folders. So it gives me more information. So software designer need to identify this, all these extra component. By the way, Mr. Rizwan, what's so difficult about that? I have 5 modules. Let's do 5 folder. I'm done. No, what you do, you just mention the module. The issue now, what are the components in the module? Remember, you're going to pass this diagram to your programmer. Your programmer will end up asking, what are the things that I need to code? What do you want me to code? Okay, let's zoom in again. Okay, I just want to show you how deep this can go, right? So now from this first layer, architecture, now I zoom in. Okay, let's say this is business logic. So this is business logic and these are the item in the business logic. Now let's say I zoom in, let's say, okay, let's say I zoom in payment. Okay, so inside payment, okay, now I have payment. So now the name will be like this lah. Business logic, student dash payment. So this is the name of the component. So here I need to identify what are the classes. Maybe only for payment under student module, I'm going to have, let's say, 10 classes. And then I need to identify how the classes communicate with each other. So this is your task as a designer. Okay, this is the task of a software design. And that task is called component design. Okay, and number 3, after you have done the component design, you identify how they communicate. Sometimes you also need to talk about database design. But there is also sometimes you need to talk about GUI. But nowadays, in modern development, GUI usually is handled by another team. We call them as the front-end team. What happens is that they will prepare a GUI based on the data that you send, which is the interface. That's what I said. That's why we need the interface to allow multiple department, multiple team, multiple functionality team to communicate with each other, so that after that you can develop on your own. Once you identify the interface, you don't have to communicate between team anymore. You just do whatever that you need to do for that particular team or for that particular module. Make sure you identify first how do we communicate, and then you do your job, I do my job. Alright, same goes to GUI. The front end team, they will do the GUI as long as they know what data do I need to pass to the user and what data that I will receive from the user. Then they will prepare the GUI based on that definition. So that's why interface design is so damn important, for you to make sure that your work can be done smoothly and then isolated from any kind of unnecessary communication between team members. Okay, detail design goal. At the end of the day, why do we need detailed design? Number 1, as I said, we want to create a blueprint for code construction. Different to architecture, the main goal of architecture is to provide reason how the structure that I choose can support the quality objective that I'm going to that I aim for. Different, the goal is different. Architecture is not just about providing the fundamental structure of my system. That is not really important. The most important thing is this: how does that fundamental structure can help me to achieve the quality objective? If I have a fundamental structure but it doesn't support my quality objective, then your fundamental structure is useless. Okay, In design, why do I need to identify all the component and then what are the classes inside the component so that we can provide the blueprint for code construction? Remember, we are now talking about functionality requirement. What is the end product of functionality requirement? Coding. Who will do that? Your programmer. So you need to give information to your programmer. What class to do, what module to do, what folder or what package does he need, right? So he need help. He need more information. So that will be the first objective of detailed design. Number two, to build this from requirement model, so we are confident that all user need to be to be met. As I said, every single design component, every single class diagram, every single component diagram that you draw or that you create must map to a specific functionality requirement. It must be mapped to a functionality requirement. The class that you do is for which functionality requirement. If it is not for that, if it is not for any functionality requirement, then explain why do I need this class. If not, throw it away. Or I do this so that I can display flower on my GUI. No need. Okay, KISS. Make it sweet and simple. Okay, short and simple. Focus on the requirement. Okay. Then next, to create a design model before coding, so to start so that we can compare different possible solution and evaluate efficiency. Okay, to evaluate efficiency. So the reason why we don't write code immediately after architecture, because let's say I create one. Okay, let's say from that diagram I identify 10 classes under folder student payment. There are 10 classes. But when we conduct review, maybe one of my colleague or one of my design team says, Ridwan, how about if we do it like this, blah, blah, blah. We can merge some of the classes. Then from 10 classes now become, let's say, 6 classes. Right. Imagine if that is in coding. You already write 10,000 lines of code. Then suddenly when we conduct code review, suddenly your senior say, hey, this one no need lah. This one can combine. This one can combine. Horrible, you know. Don't change code. No. Try to minimize changes to code. But what we do, we focus on change the model, change the suggestion, the plan. Okay, then only we give to programmer to write the code. Okay, so basically we want to see how many alternative solution that we can create, and for each alternative solution, we want to check the efficiency, the ease of modification, and also the maintainability. How easy can we maintain them? Okay, one question you said, Rizwan, when we identify the architecture, you said we already cover the efficiency, maintainability, and whatnot. That's true, but that is between layer. That is between this and that and whatnot. But the issue now, the moment a software designer do the second part and they start to introduce component, and each component need to communicate with each other, there is also an issue of maintainability. How easy can I maintain the code in that particular structure? Let's say I'm using model view controller. So if I introduce, let's say 50 component under model, okay, under structure model, I have 50 component. The issue now is that how easy can I modify that code later on. So some discussion about maintainability, efficiency, and also easy to modify also need to be discussed, even though that is not the major discussion. Okay, but still required. Okay, quality of a good design. So now we have discussed about the goal. We have identified what does it mean by detailed design? Why do we need detailed design? Now we go to the quality. How to say that a good design is really a good design? Number one, just now we said don't overdo things. Okay, don't overdo things. Don't add non-necessary element. Okay. Now next we say correctness. It should lead to a correct implementation. If the component supposed to handle login, then it just focus on login. Don't mix up that component do login, at the same time the component also do output display, at the same time that component also do input verification. So that component handle too many tasks. Don't do that. So one component, one objective, or one task only. Okay. Next, completeness. It should do everything. How do you want to measure completeness? How do you know that your components are complete? As long as you can map all the functionality requirements from the SRS to the component that you develop in the design. Then completeness considered done. Right? Number 3, changeable. How fluid your design is. How changeable your design is. Okay, so this fall under modifiability and also maintainability. Because sometimes if you do, okay, one reason why a design or a component relationship will be difficult to change. One reason. Usually only because of this reason. I banned the 4 of you. Quarter of questions already full. Anybody? Anybody? How do you want to know? How do you want to know that when you look at that particular, okay, let's go down a little bit lower to something that you always do, class diagram. Maybe some of you are not familiar with package and component. Okay, let's go to the lowest design, which is class diagram. How do you know when you look at the class diagram, immediately you say this class diagram will have difficulty if I want to do modifiability or changes in the future? Alright, high coupling. Thank you so much. Alright, so high coupling. The moment you look at the diagram and you see, wow, the coupling between classes are very high, then immediately you know that your design elements is not maintainable and not changeable. So that's what we mean, changeable. It should facilitate change. Right? You cannot be too egoistic that say, oh, my code can handle any form of scenario. No. System is very dynamic. Sometimes we do need changes from time to time. So your code must be able to change. Right? For those who still cannot understand this, change, when I say change, we don't say just change code line 1 until line 50 or whatnot. Sometimes I do want to inject extra classes. Sometimes I want to inject extra folder, extra package. Sometimes maybe I want to introduce an API. So when all these new elements come into the existing component, so how they communicate, how easy for them to communicate. Okay, for example, let's say I want to introduce one extra class here. Okay, let's say I have 10 class here, right? Ui. Work hazard. Work hazard. But there is no insurance provided. Okay, let's say I have 1, 2, 3, 4, 5, 6, 7. I have 7 classes here. Right, let's say in the future I want to introduce 2 more classes. Right. The ideal scenario, let's say like these 2 classes are related to this class. So by right, it should only be like this. Right, should be like that. But somehow, maybe due to high coupling, what happens that when I want to introduce new element, I also need to do changes here, I need to do changes here, I need to do changes here, in order for these 2 new elements to talk to this diagram or to this particular class, but I need to do changes here, here, and here, for example. Meaning that you have a high coupling. So this is not a good design. You should minimize changes. So meaning that when I identify who is the existing class that I need to disturb, right? But if I disturb that class, will it affect all the other classes inside him? So if it affect all the other classes, meaning that your code is high coupling. The classes are too rigid. The classes have too we call it high intense communication between them. They are not separable. That will be very, very bad. Okay. So the component also must be efficient. Efficiency means the ability to perform at a high rate with lower sources usage. That is called efficiency. Because I received some question, what's the difference between performance, high performance and high efficiency. High efficiency means that the ability to provide outcome at a very fast rate by using a small amount of resource. Right. For example, you want to achieve transaction 1 second for every transaction. But in order to achieve that, I need to use 1 tera RAM. 1 terabyte or 1 terabit, 1 terabyte of RAM. That is doesn't make sense. Right? let's say I have another designer, I can achieve 1 second response time by using maybe only, let's say, 64 gig RAM. That one is called high performance, high efficiency. But if in order to achieve performance, I need a lot of resource. I need a lot of CPU power. I'm using a lot of RAM. That one is high performance, low efficient. Same goes to your code. Unfortunately, we don't discuss that in our syllabus. But if you do take your masters, try to find a master program that discuss about code performance. Okay, we give 1 minute for him to settle down. Alright. Code performance is a very interesting thing for you to discuss. Code performance, components performance, very interesting thing for you to discuss. Alright, how can you write code to ensure, but it give you high performance, but use a low CPU time and low RAM. So that discussion, unfortunately, we don't include in our syllabus. And lastly, simplicity. Right? Lastly is simplicity. Make sure your design can be understood by everybody, not just you. Okay, not just you. Try to make sure you include everybody to understand your design. Okay, done. So let's go for a 5-minute break, then we continue.
Nandun ay.
Something that is in the lecture slide can be interpreted in different Okay, for those who are concerned about the midterm, especially those who are not familiar with my style for asking question, usually lah for midterm I can be a good guy. A little bit definition question here, a little bit list of things here. But most of my question are applied based. I like applied question. Means that you will be able to memorize it, but the issue is that will you be able to use that information in the notes and apply it to a certain scenario. I like that kind of question. Okay. For final exam, question related to list, define, I just give 15 marks total.
Oh, so can pass ah.
Right? So if you score that question, yeah, you can get 15 marks. But the rest are all applied question. Case study. That is my style. So, and one more thing, I don't like paragraph. Don't give me paragraph answer. If I said three, let's say if I said describe 3 reasons, so immediately reason 1, 2, reason 2, 3. Don't write the first reason is next, second reason is, and the best thing, the 3 reason for. Oh no. Please lah, I have 158 question paper to mark. Help me. Right, and then don't waste time for you to copy my question. 3 reasons are first. You're not writing novel, right? Remember, you are here because you choose to be here, not your parents ask you to be AIT. You are not writing novel. Help me. So if I say 3 reasons, pop. 1, reason 1, 2, reason 2, 3, reason 3, done. Usually my question also will state clearly how many points do I need. Okay, so don't worry. I will not say, give your reason, 10 points. Then you ask yourself, 10 points, 10 marks. 10 marks is what? 10 points? 5 points? Maybe only 2 points with 5 marks each? No, usually I will say, if I say 10, I want 10. If I say 3, I want 3. Don't worry about that. Alright, any more questions about the midterm? Don't worry, midterm will be easy. Don't worry. Midterm will be easy. Even my final exam this year is also easy. Don't worry. Any question about midterm? Any worries? Any? 4 吧? Huh? My classroom say 1 2 1 2 3 5. 1 2 3 5. Sorry. 1 2 3 5. My tips are
1, 2, 3, 5.
summarize each slide in 1 sentence. You know, right? I like that activity. Okay, cool. I always tell my group, if you really understand a particular concept or topic or idea, summarize it in 1 sentence. Then you are good to go. Right? So that's the only tips I have for you. For example, what is the definition of for example, the importance of software design. Okay, now in the slide we have 1 2 3 4 5, right? But summarize it in 1 sentence. Yeah, then should be okay. Right, let's proceed. The design activity phases. So these are the activity that you must do when you do detailed design. So there are 1 2 3 4 5 6 activity. But actually it involves something that we already done. So now we have 1. So this is done. This is architectural design. So this one is done. So now we are here, from here to here. Alright, so this is called detailed design. Okay, this is called detailed design. Alright, however, detailed design can be divided into 2 sections. So now one is called high level detailed design. Another one is called low level detailed design. So how do we start? In high level detailed design, we start with abstract specification. We need to identify software specification. Okay, abstract specification. Alright, after you identify your architectural design, you need to come up with abstract specification. Abstract specification means, how to say? You need to identify what are the things needed for me to implement the functionality requirement. But you don't focus on how do you want to do it. That will be handled by the last activity. So abstract specification, in other words, you need to identify candidate for your component. What are the components that I need to put inside each structure in the architecture diagram? So meaning that rough idea, the general idea, what are the things, what are the components needed and what they do. That's called abstract. Abstract by definition means to focus on things an element do but not how he do it, right? So that is called abstract. So abstract specification means that after my architecture is done, now I need to identify component. Question is, what does the component do? That will be the question. Why do I need this component and what do they do? That's it. How to implement the component? What are the classes inside the component? We leave it for another stage. For now, we just want to identify what are the components and what they do. Why they need to be there? Okay, why they need to be there? For example, let's say this is my GUI layer. So under my GUI layer, let's say I have 3 components or 3 package, and they communicate to each other like that. So at this point, it only answers what the package do. Alright. At the second part, abstract specification, we only ask this question: what the package do. Alright. Then after you are done with that, you go to interface design. So now using the package diagram that you have, now you need to identify how does this package communicate with each other. What parameter do I need to send from one package to one package, and what are the return value? So let's identify the interfaces. Once that is done, then only we refine the component design. What do I mean by refine? So now it's time for us to give more detail about this package. So let's say I zoom in this one package. Let's say I take it out. So now my question will be, what are the elements in this package? Maybe I can have another sub package, or maybe I'm going to have component, or maybe I can have classes. So this is called component design. Alright, and then how each of the sub element communicate to each other within this main folder. That is component design. Okay, when that is done, okay, now up to that point, we only touch on structure. We only touch on plan. So we are creating a plan. We are creating sort of like a map for our programmer to write their code. Okay, so up to that point, we are doing high-level detail design. So we call it as high-level detail design. Okay, once your component design is complete, now we go to low-level component design. So this is actually coding. We are now touching on coding. Do you remember slide from chapter 1? There is one diagram that say software design is divided into architectural design, then you have detail design, and lastly you have construction design. So now, when you do low-level design, what you are actually do is this. You are doing construction design. So construction design is also part of detail design. So this part here, this part over here, from here to here. So now this is called construction design. Okay, construction design. So what construction design do? So we do data structure and algorithm analysis. Now, let's say I have identified, let's say, 4 classes for this folder. So I take this class. Okay, I have one class. Okay, let's say class X, and then I have a few methods. Okay, I have a few methods. So what happens that from all these methods, suddenly there is one particular method that is very critical, and you believe your programmer needs some kind of guidance to write the code for this particular method, even though you provide some kind of definition or description about the method. So what you do now, you help your programmer by providing an algorithm. Okay, or you can also provide him a pseudocode. Data structure. Here first, we need to identify the data structure needed for every single class, right? Do you want to use a list? Do you want to use a file? Do you want to use a queue? Do you want to use what else? List, queue, stack, or you want to use tree, blah blah blah. So identify the data structure first. Then you do the last one. The last one is called algorithm design. Do I need to create algorithm for every method for every class? No, not necessarily. But you need to provide description. For every method, you must provide some kind of description. What does the method do? What is the expected input output? Okay. Remember when you learn data structure algorithm, you have that one file where you need to write the name of the method and then the precondition, the postcondition, the input, and also the body of the method where you write the algorithm, right? That kind of thing need to be provided. However, the algorithm only provided for critical method. Means that let's say you have a function that is so important, you cannot allow any kind of error to happen. Right? So what you do, you provide the algorithm to the programmer and then the programmer will write the code based on that algorithm. So that is called algorithm design, which is the last activity. So this is detailed design. Okay? This is detailed design. Your assignment only stop up until here. Okay, your assignment only stop up until component design. Oh, by the way, when I say interface design, this is not GUI. No, this is not GUI. Nothing to do with GUI. Interface design is the definition how two components communicate with each other. Parameter passing and the return value. That's all. Okay, question about activity in software design. Alright, moving on. Okay, so this okay, we have identified this. Right, software process component design, algorithm design, done. Okay. Okay, now we want to do approach. Okay, now I know what are the activity inside what are the activities needed for detailed design. I know the goal, I know the reason, and so on and so forth. Okay, now approach. Approach means that how do I start? I have my architecture now, but how do I start my detailed design? I know that the first job that I need to do is abstract specification. Identify the component that is needed for every structure in the architecture. So 3 layer, I have 3 structure. So for every structure, GUI, business logic, the data layer, what are the components that I need to put into them? And that one is called abstract specification. The question now, how do I start? How do I start? Okay, so that you have to answer for that. You can either use top-down design or you can use bottom-up design. So what is a top-down design? Top-down design is basically an approach that allow you to start the design process by identifying things that is most generic until you identify something that is very specific. That is the normal thing that we do. Meaning that you start from the architecture, you identify the component, you identify the sub-component, you identify the class, you provide the algorithm, you provide the data structure, then you are done. Very generic architecture, very detailed algorithm design and data structure design. So from top to bottom. Okay, same goes to identifying module, right? You identify module from the system, university management system, then you divide it into 3. In SRS, you also do that, right? So in SRS, you also do the same. You start with university management system and then you divide it into 3. For example, finance, academic, student. Right, under finance, you split into human salary and fee. Under fee, you split into penalty and academic fee, blah blah blah. So this is called top-down approach. Same goes to software design. You can start from the top and then you go down until the most detailed part, which is the data structure and the algorithm design. However, there is another approach called bottom-up. This is done or this is used if you have a legacy system. Let's say you are hired by a client to develop a system, but he says, I have a system. Okay, for example, I already have a post system. Right, I already have a post system. Point of sale. Okay, I already have a POS system, point of sale system. So I place that, let's say I have a small grocery shop. Okay, I have a small mini mart grocery shop. Right, so I put that at the cashier counter, I scan, and then the system will capture the price, and then it will give me the total sales for that day, and how many unit per item that I sell for that day. However, all this input will just go into an Excel file. For example lah, I don't have an inventory system. So every day before I open my shop, I need to key in manually into the POS how many items for no, there is no inventory system. So basically the POS only capture the price, the unit, and the total sale for that day. Right? But I don't know how many items still available in my inventory or whatnot, for example. Then you are requested to develop a system, an inventory system, and then that new system must be integrated with the POS system. Let's say the client say, I do not want the POS system to be removed. I still want to use the POS system. All my staff are very happy with the POS system. What I want you to do, I want you to create an inventory system that will integrate with the POS system. Okay. So as an architecture, this is what we call a legacy case study. Right? So what we do is that we don't start from the top. We start from the bottom. How do we mean by we start from the bottom? We take the legacy system, we take the POS, and then we identify all the components inside the POS. Okay, so that's how we do it. Actually, I'm tired. Okay. Alright. So now this is my post. Right. So now I need to know what are the elements under post. Alright, in the legacy system. Let's say I identify inside this POS system, POS, point of sale. So let's say I identify there are 5 major components. Okay, so as an architect, I will not start from the top. So what I do is that I try to identify what are classes, or okay, let's not talk about classes. We go a little bit higher. What are the components that I need to create that can communicate with this POS system? So I start from the bottom, right? Identify what are the components that I can create that can talk to this system, right? Then, once I identify the component, then I identify the folder. Can I group all these components into different category? Right, now I have component, I have folder. Then I go a little bit higher. Okay, this component will go to which architecture structure? This will go to which architecture structure? Which architecture structure? So you're going to ask me, Rizwan, that doesn't make sense. I don't identify my architecture yet. So what you do is that from the communication between the folder to the legacy system, then you can identify the architecture that you want. So actually the architecture is already in your mind, just that we don't specifically mention it yet. But as you grow up, as you go higher, then you will identify the architecture and where do you want to put this particular component. So that is called bottom-up approach. Identify the component that can talk to the legacy system, and then group the component to become a structure or a folder or something, and then identify architecture that can use all these components that you have created. So that is called bottom up. Okay, bottom up. Why we cannot use top down for legacy system? Because if you use top down, there will be a situation maybe the architecture doesn't. When you draw the architecture, end up you do not know where to put the legacy system. You do not know where to put the legacy system into the architecture. Because you don't understand the legacy system yet. What you do, you start from the top and then you go down. So you might end up with mismatched component that cannot talk to the legacy system. So because of that, if you have a legacy system, always start from the bottom. Then you go you go up. So that is called bottom-up approach. Okay? Question? Any question? Any question? Okay, let's say I give you one scenario. Let's say I have a client already have a legacy system. Let's say I call it as legacy system A. And then after doing the requirement study and whatnot, then the software analyst tell me, as an architect, he tell me, Rizwan, I suggest that we remove the legacy system. Why? Oh, the legacy system, even though are still working well, but it is too old. The technology is too old. So we already informed the owner that he should remove the legacy system, but he doesn't want to. He still want to stick with the legacy system. So maybe as an architect, you can tell him that we should remove this legacy system and change it with a new technology. Let's say you agree with the system analyst's decision. What argument that you want to bring forward for the owner to consider? From analyst's point of view, he can only say to the owner, for example, like, Ridwan, you should remove this because if you develop everything from scratch, it will be more easier. Your system will be, you can cover more function and whatnot, blah blah blah. More on the surface, right? More from the function requirement test. Okay, let's say you are the architect and then you agree with the analyst. We are not forcing the client to remove the legacy system. No, we are suggesting. So what point do you want to raise when you meet the client and say, I would like to suggest that we remove this particular legacy system? How an architect want to put that into words so that it is easily understandable by people? Remember, you are a techie guy. When you are a techie guy, there is a possibility you will talk nonsense. Right? There's a possibility you thought that only you can understand because you are a software designer, right? Remember, your client is not a designer. Right, now, what argument that you want to bring forward? Anybody? ROI? No. No, we don't talk ROI. Why? Because when you talk ROI, you will talk cost. Anything that involve cost, usually client will reject immediately. Don't bring money into the discussion. Anybody else? What is the task of an architect? The task of an architect and software designer is to create a structure for the system. Number one, to identify what are the components needed for me to implement the functionality requirement. That's it. So basically, you're talking from the internal movement of your system. You talk about what is inside your system. Analysts, SRS, only talk about what the system do, which is outside, right? The outer side of the system. Now, the system analyst asks you to talk to the owner, to pujuk him to remove the legacy system, but you want to bring into the discussion point related to the internal working of the system. You cannot say, Mr. Ridwan, we should remove your legacy system because from 3-tier layer architecture point of view, we should receive maintainability order. I said, what the heck? Thank you so much for the lecture, go home. I still want my legacy system. Yes, Chris. You raise your hand, right? For whatever reason, you raise your hand, right? Anybody? As an architect, you want to pujuk this old man to remove the legacy system so that you can start from everything from scratch. But you want to give the argument by talking about the internal working of the system. Why I should remove the legacy system from design point of view? Huh? Too obsolete. The technology is already obsolete, but still working, doesn't matter. ATM machine up until 20 something. They still use Windows Windows XP, and they still use Java 6 in the ATM machine. Why they don't do it? Because they say there's no error, why change? You know, right, when you update your Java SDK from 6 to 7, 7 to 14 and whatnot, some code will be deprecated. D-E-P-R-E-C-A-T-E-D, deprecated. Means that the code is no longer workable. So what you need to do, you need to remove the code, replace it with the new code from the new SDK. Imagine that, doing that for a system that is already stable, buang masa, right? So many ATM machines still, before the touchscreen come in before the touchscreens come in when they use button 100%, at that time they still use Windows. If you open the ATM machine, you can see there is a PC, Windows XP, Java 6. Well, because one of my system is a senior programmer at my bank. Oh. Right. Lately baru they update, but they don't update much because they don't want to disturb the flow. Okay, back to my question. From designer point of view, how do you want to say, let's remove the legacy system? Then you don't take my project you go away. Let's cancel the project. Thank you for preparing the SRS. I'm going to pay you up to SRS only. Okay, then I find another architect. Other than that, you guys lack of human touch lack of diplomatic skills. Anybody else? Yeah. Actually, I just want to say. So, think about it. Now, that might appear in your final exam or something, right? So, yeah, think about it. That kind of question might appear. That kind, you know. Okay, think about it. From design point of view, why do I want to remove the legacy system? But if I do not want to remove the legacy system, no problem for me. I can start my work from bottom up, right? I can understand, learn, and then I can go up. Not yet. From my experience, just want to share with you. From my experience, I only had the experience to work with legacy system once in 2002 when I did my internship. That's the only time I ever see a legacy system. Internship with the IT system in USJ Sembilan. Now they moved to Cyberjaya. So they were working with Bukit Aman at that time to improve the message transmission system between Balai Polis. The work is quarterly done by one big company, Alcatel. The Alcatel company do the work halfway, not even halfway, quarter way of the job, then they abandon the project for, I'm not sure, the reason was not disclosed. Because I'm just an intern, right? You don't ask things, right? But I still remember the first day I come to the internship, the first task was to learn ASP. At that time it was ASP. In school, I learned JSP, Java Server Pages. First day of internship, ASP, Active Server Pages from Microsoft. So my supervisor gave me a manual, a sample of a system. I learned everything on my own. He disappeared for 2 weeks. On that floor, I'm the only one always there, always come to office. On that particular floor, I'm the only one who come every day. In week 3, he come back. Okay, you know how to develop? No. Write me one simple page. Right on the spot. Okay, done. Next day, let's go to Bukit Aman. So when I go to Bukit Aman, then only he explained to me the project that we are doing, and then I'm just going to do a simple module. I call it as error log. Meaning that to allow user to submit error or to raise error if they find any error in the system. But in order to do that, I need to understand the current communication system, and then I can see like 3 boxes of documentation from Alcatel. I just need to study one document from that 3 boxes. Imagine my company at that time need to study that. And then they decided, let's continue. So what they do, they build on top of whatever Alcatel already built. It takes time but the project was a success That was the only time I ever worked with a legacy system. Then after that, no more. I think nowadays people ask you to remove the legacy system. Okay? So, yes. My company still works well. I can still run my operation. So why do I need to remove my legacy system? Pujuk me some more.
Not efficient. Not efficient.
Okay, ask and assess your own on your own. Okay. Right now, principle. Okay, now last topic before we go for another break. Software design. When you do software design, there are a few value that you must include in your work. Same like software engineering. Software engineering also have its own principle. Can you name me at least 4 most important principle in object-oriented programming? Abstraction, inheritance, encapsulate, data hiding, reusability, alright, polymorphism. All those are the pillars. We call it as the pillars of object-oriented programming. That's why I always tell DSA student, data structure algorithm student, you may write a Java code, but you may not write an object-oriented code. Okay, what do I mean? You write a Java program code, it can write, it produce output. But if your Java program doesn't include all the principle of object-oriented programming, then you only write a Java code. Your object-oriented code is not there. Can I reuse your Java code? Okay, does your Java code have encapsulation and data hiding? Blah, 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 blah. All those factors need to be taken into consideration. Same goes in software design. I said just now, completeness of software design if you can map the element to every functionality requirement. Correct. Correctness means that somebody must be able to review the outcome is correct. Correct. But at the same time, you need to include all these principles to ensure that your design work is a good design work. Number one, abstraction means that your software design, starting from component starting from architecture up until component design, you only focus on abstract information. You only focus on what this component do rather than what the component will do, because that will go under construction design. When you define the pseudocode algorithm data structure, then only we discuss how the component will be implemented. Right? When you identify the component and the classes, we still haven't touched on how the component will be implemented. So always focus on abstraction. Focus on what the component do and how does the communication happen between multiple components. Number 2, decomposition and modularization. Always split the design component into smaller component. Don't have one component that do multiple objective. Okay, don't. For example, like let's say you write a Java program called shape.java. Shape.java. Inside shape.java, you have one function that receive input, one function that calculate the size of a circle, one function that display the output of the circle, the size of the circle. Does that fulfill decomposition? No, because that shape.java do 3 different things. Receive input, do the calculation, display. How come shape.java display output and receive input? Right, that doesn't make sense. For example, I am lecturer. So let's say I have lecturer.java. Suddenly I have one function, borrow money to student. Banker. Borrow money to, I have one function, borrow money to student bracket. That's not my job, right? So meaning that if you create a Java class with that functionality, so meaning that Java class is no longer fulfilling decomposition and modularization. Make sure that each component have a specific function and objective to achieve. Then you have decomposition and modularization. Encapsulation, always hide the detail. For example, when I say hide the detail, right? When you are describing the architecture, right? The only thing that you need to show is just the component, right? Just the component. You don't need to show what is inside the component because that will go to another chapter of discussion. Right, so that's what we mean by encapsulate. encapsulate and information hiding. Right. Number next, okay, this is the most important of everything, coupling and cohesion. So last 2 weeks or last week we already discussed what is the definition of coupling and cohesion. So again, let me refine that. Coupling means that two different components with two different objectives communicate with each other. Or not, let's say two, let's say more. Let's say a set of components A, B, C, D, E. Each one have different objective or different aim, but they communicate with each other. Make sure the communication is limited. Means that usually one-way communication only, and try not to get involved with every component. For example, let's say I have A, B, C, D, and E. So let's say, okay, this is a good okay, this is a low coupling design. Okay, this is a low coupling design. Somehow you are able to minimize the communication between the component. Number one means that only A call all the component and only B can call D. That's it, done. Right? And then what you minimize the communication, and then all the communication is one way. So this is called low coupling. But if you do something like this, now you have high coupling. Right? How does high coupling come about? Because you don't have a proper plan. This is what happens if you let your programmer write code immediately, because they don't have a proper plan. So that's why a designer need to give a plan, a blueprint to the programmer to write the code. Right? What is cohesion? Cohesion is like this. So now let's say I have this is 5 different components with 5 different objectives. Let's say I have A to B, B to D, A to D, A to E. Okay, this is low coupling. Done. But when I zoom in into B, so if I look the detail in B, let's say I have 50 classes. Okay, I have 50 classes. But the classes talk like madmen, right? There's no specific rules that they follow. But what happens is that all of them are working together to achieve the objective of B. So this is called high cohesion. Okay, high cohesion. So same goes in your design. When you do upper layer, starting from the architecture, make sure the communication is minimized and usually in one way. Then when you go to the next layer, which is the component inside the structure of the architecture, remain the same. Identify the component, what is the purpose of the component, and then what is the communication between the component, usually one way, and try to minimize the communication. And then if you have another sub-layer component, also do the same. But the moment you enter class diagram or class layer, that one, you can have some leniency. You can have some crazy communication between classes, because they are considered as cohesion. But still, not try to, if you can control the coupling, the much more better, right? If you can control the coupling, much more better. So there are 3 types of coupling. One is called content coupling, common coupling, and data coupling. Content coupling refers to modules that modify or rely on the internal detail of other modules. So this is called content coupling. Right? When you have too many people talking to each other, I need you, you need me, I need him, blah blah blah. So that is considered as content coupling. Right. Then we have common coupling, refer to dependency based on a common access area, such as global variable. So you have, okay, now in programming, global variable is totally prohibited. How many of you like to use global variable? Right, some of you, sometimes you misuse the attribute, the class attribute or the class field. I know some of you you purposely put integer A and then you put as at the top of your class. It become a class attribute. Why? So that you can use the A or in all function, right? So So you are misusing that to become a global variable. So try not to have a global variable, because the moment you have a global variable, it is shared by all. So now we call it as common coupling. Even though you don't create the communication between the component directly like this, but since you create one global variable and that global variable is shared by E, A, B, and D, then you are creating common coupling. Also not a good design decision. And lastly, data coupling. Refer to the type of dependency in which design unit communicate with each other only through a why hey view okay, only through a
A set of data parameter.
a set of data parameters. Alright, a set of data parameters. Data coupling refer to the type of dependency in which design unit communicate with each other only through a set of parameter. Imagine the data-centered architecture. You have multiple components, right? But each component cannot talk to each other. So what they do, they talk by sharing data. So one component modify a data, and then another component pick up the new data. So that is one is called data coupling. Usually for data coupling, no problem lah. Data coupling shouldn't be any problem. Our most main concern will be common coupling and content coupling. Right? So try to avoid that. Okay, so what we want to achieve is this cohesion. Okay, what we want to achieve is cohesion. This is the main principle that we want you to include inside your software design. Right, the manner and the degree to which the tasks performed by a single software module are related to each other. Right, the manner and degree to which the tasks performed by a single software module are related to each other. So a single software module, let's say B is a single software module, but all the components inside them are communicating with each other to achieve the objective of B. So this is called cohesion. So there are three types of cohesion. Functional cohesion, all tasks in a design unit contribute to perform a single function. All tasks in a design unit contribute to perform a single function. For example, I have one class called verified user ID or verified user. Right, I have one class called verified user. So the function of the class is to do verification. So all the method needed in that class is considered as functional cohesion. Right? Procedural cohesion. The task work procedurally in steps to achieve unit purposes. For example, like this lah. This can be considered as procedural cohesion. Different classes with different functionality works together step by step in order to achieve the objective of B. Then we have temporal cohesion. All tasks in a design unit are performed at a specific time. So this more related to imaging pipe and filter. I said last week, pipe and filter is a good architecture if you have a system that only run on a specific time frame. Right? So all elements that work in that time frame to implement the architecture is considered as temporal cohesion. And lastly, communication cohesion. The tasks produce or consume the same data. Okay, its tasks produce or consume the same data. So that's why it's called communication cohesion. Alright, at the end of the day, we want a very highly cohesive software element, but a very loose couple. Right? What is the main reason for high cohesion, low coupling? What actually the main outcome? Main reason for high cohesion, low coupling, so that you can easier to modify. Yeah, true, but actually easy for us to reuse. Right? When you have loose coupling, if I want to reuse a certain component, I don't have to pick up everything and then put it into the new system, right? I just pick up one component and then put it into a new system because it loosely coupled, mean that it doesn't depend too much. Right? Not a good scenario. Let's say you have 5 boys who are single, right? They are very high cohesive. Whatever they do for the brotherhood of the 5 people, right? One person have a girlfriend. That's where the coupling come in. Wherever the boys go, the girl follow together, right? See, we cannot reuse the boy anymore, right? I take the boy to watch cinema with the other 4 boys. I have extra person. That's called high coupling. Sometimes high coupling is not good. Okay, so there's some life education you can take from there lah. Okay. Question about cohesion and coupling. You got my story or not? Okay, it's okay, up to you lah. Right. Any questions? Okay. Next one. Separation of interface and implementation. This is also important. Okay, now why this is so damn important and being keep repeated many times. Okay. I'm going to use up until 8, don't worry. Okay. Okay, let's say I have 3 components, and then I already decided that these 3 components will be developed by 3 different teams. Okay, team from US, team from Australia, and team from Malaysia. What structure am I using right now? What architecture structure I'm using right now? Allocation, thank you. Right, so now the team in US, Australia and Malaysia, of course they have different time zone and whatnot, so it will be very difficult for us to communicate. So the idea is that you are supposed to develop the system on your own, isolated. Then once done, we integrate. The issue now, how do you want to ensure that the integration is a success? What you do, you need to define the interface. So that's why I said again and again, you need to define the interface. What value do I send, and then what value do I get back in return? Define that first. Regardless which class that handle the input that come in and which class that provide the output that goes out, doesn't matter. But as long as we know, this component requires some input and it will give you some output. How does it happen? Who does it? Doesn't matter. Identify that first. Alright? So when I split the work, US team, Malaysia team, Australia team, so when I start fill in the gap and start introducing more sub-component and class diagram, as long as there is somebody who receive the input and produce the output, then I'm good. The integration should be successful. So that's why we need this separation of interface and implementation. Don't simply allow communication between components to happen without you identify and define what is the interface. Again, without a proper interface definition, reusability will be a total loss. You cannot reuse if you cannot have a good definition of interface and implementation. Okay, sufficiency and completeness. Okay, this is go back to the previous slide. Basically, make sure whatever that you do is considered as sufficient. Don't overdo your design. Don't take too long for you to do your design. You take 6 months to do one design. No, that's ridiculous. Alright? So, there are 2 issues. Completeness and sufficient. Alright? Sufficient means that as long as you cover all the functionality requirement, that is considered as sufficient. Right? Same goes to completeness. As long as you cover all the functionality requirement, then completeness is considered achieved. Right? Sufficiency and completeness. There is no such thing as, I need to add more, there is something more missing. No, we don't do that. We don't spend we spend a good amount of time on design, but don't overdo it. Don't exceed the time required for that. Okay, let's go for 5-minute break and then we continue.
看不到，没关系。没有，我只是前眼的不好做，因为我就有那种。
Alright, sorry, I forgot the last element, the last design concept and principle, separation of concern. What does it mean this? When your architecture is done, when your software components are done, when your algorithm is done, when everything is done, your software design document is ready to be distributed to all stakeholders. So what happens that the information provided in the SDD should be able to answer different questions provided by different stakeholders. That one is called separation of concern. For example, if a client asks, how can you guarantee me that this system can achieve, can increase the number of users by 10% in the next 5 years? How do you want to answer that? Okay, your SDD is ready, your software design document is ready, similar to SRS, we will write in a document called SDD. Then you distribute all the SDD to your stakeholder. Then your client asks this question. Okay, from this document that I don't understand, show me which part that discuss that the that the system that you're going to build me can help me to increase the number of users by 10% in the next 5 years. So which part of the SDD that going to answer that question? Brother Jim? You have a complete SDD. You distribute to all stakeholders. As I said, separation of concern means that your everything that you do in software design able to provide different information to different stakeholder. That is called separation of concern. Right? Okay, now you give the SDD to your client. Then suddenly your client asks this one question: which part of this document that discuss about the ability of the system to increase the number of my client by 10% in 5 years time? Architecture. Why architecture? Software architecture talks about quality objective. If you are able to achieve quality objective, that means that you are able to achieve the business goal. Increment of client by 10% in 5 years time is a business goal. That's why he hire you to develop the system. That's why he want the system. Because he aim, after I deploy the system, after I introduce the system in my company, I can increase the number of clients. How do I achieve that? Maybe high performance, high usability, blah blah blah. But that discussion only appear in architecture design. So architecture section. Right. Let's say your project manager asks, how can you ensure me that this project can complete within the next within the expected 7 months? Which design element that will provide you that information? A project manager come and say, Ridwan, you say that we put in our schedule that the project coding will be done in the coding will only take 2 months. Which part of your design discussion that talks about this or able to achieve that? So, Francis? Oh, by the way, for those who don't know, Francis is my class assistant, the highest rank among all the students. Francis, which part of the software design discussion, starting from architecture up until algorithm design, which one that will tell the project manager that we can achieve coding in 2 months' time as scheduled? Huh? Oh, by the way, he's already fired actually. So fired from my class as my class assistant only for 1 semester. That's all. Right, but in honor of that memory, Francis. Anybody from 134 1238? Seriously, I want to know you guys better, but yeah, my mind sucks. I can memorize technical paper, but I cannot memorize name. Don't worry. Anybody, boys from the front? Huh? No one. From architecture to component to class to algorithm to data structure, you know, right? These are the things that we do in design. Which one that give answer to this question? What guarantee that you can give me the coding activity that will be able to complete in the next 2 months as scheduled? Component, yes, because once you have component diagram, you provide a blueprint, so the programmer doesn't need to think, doesn't need to figure out from scratch. So basically, they just continue or they just write code immediately based on the blueprint provided in the component diagram. Because from component diagram, you got class diagram. From class diagram, you got algorithm and then data structure. But actually, architecture diagram also provide some information to tell the project manager what time needed for us to complete the project. Okay. Programmer, ask one question. What do you want me to do with the code that I write? I'm going to write 100 Java file. So what happened to this code? What do you want me to do with this? I rephrase. Based on the software design document, then suddenly I am assigned with 100 Java file. 100 Java file. 1.java, 2.java, 3.java, 4.java until 100.java. Then the programmer asked me, Ridwan, what should I do with this file? What should I do with this file? I have 100 Java file now. Tell me what should I do with this file? Huh? I want to know what diagram or what information that will help me. Abstract, no? Component, right? Component, element. Software component. Software component will tell me what should I do with this 100 Java file. Because software component is the final format of the code. Let's say if I have 100 Java file, let's say when I look carefully from that 100 Java file, actually that 100 Java file sit inside two components. One is called a.jar, another one is b.jar, which is two Java library. So as a programmer, what should I do? I don't need to ask my designer anymore. Looking at the diagram, starting from the component diagram, going down to the class diagram, then I know, 50 classes, zip them, become a.jar. Another 50 classes, zip them, become b.jar. So that's why we need the component diagram. We need the component information. So that is called separation of concern. Every stakeholder who read the document should have some kind of information related to their position. Okay, so that one is called separation of concern. Alright, cool. Last 3 slides. I see that then. Okay, the last one is called construction design. So this one goes back to this slide. Okay, so remember I said this last two here, data structure design and algorithm design, even though this is considered as low level detailed design category low level, but actually their real name is called construction design. Okay, they are supposed to be called construction design. Why construction design? The moment you talk about pseudocode, the moment you talk about algorithm, the moment you talk about data structure, you are touching on coding already. So we call it construction. Alright, regardless of the exact allocation, some detailed design work will occur at the construction level, and that design work tends to be detected by constraints imposed by the real problem that is addressed by the software. So software, just as construction workers building a physical structure, must make small-scale modification to account for anticipated gap. So in construction design, sometimes when we do the algorithm, suddenly you realize, this is something wrong. Maybe I need to add more function or more method, or I need to introduce new classes and whatnot. So there are possibility when you are doing construction design, when you are writing the pseudocode and the algorithm, you feel that, this algorithm is too big. It should not be handled by only one method. I need to split this into a few more methods. Then you can tell the designer, can we introduce new classes and whatnot. So that one is called small-scale modification. Alright? Software construction workers must make modification on a smaller or larger scale to flesh out detail of the software design during construction. So there are some detail that might be hidden or cannot be seen until you really look at the class and you write the algorithm. Then only you feel like, this class is too big. Let's split this class into 2 extra class. Right? So that kind of discussion should be done lah. But in my personal opinion, if you do your class diagram correctly, if you do your software design pattern correctly, not architecture pattern, I'm talking about design pattern, chapter 5. Then by right, when you do construction design, there shouldn't be any issue about error on the class structure and the component structure. Right? But yeah, error can happen. So construction design is only about creating an algorithm, data structure, and interfaces. Again, the word interfaces come in, but now interfaces between method. Interfaces between method. When a method call another method, there will be some parameter passing also, right? That also involve interface definition. Right, that's all about construction design. So basically, construction design can be summarized as the last activity in software design where we focus on creating or providing a guidance to the programmer by giving them some pseudocode algorithm and data structure definition. But at the same time, construction design also will be able to help you to identify any hidden errors or any extra things that you might want to add into the design. So basically chapter 3 is just an introduction to detail design. Alright, so next week we will be discussing about strategy in software design. So if I want to use software design, I have top down, bottom up. But there are also a few other strategy that I can use. Okay, so that will be for next week discussion. Question? No, not yet. Buka puasa, is it? Oh, any question? Any concern? Anything you want to share with me? Anything that you're not happy with? Okay. I'll see you on Wednesday. Right? Bye.